Let's jump into some derivatives. So first we have f of n equals e to the n. Well, we know that e to anything is itself. So it would just be like saying e to the x. So the derivative for e to the n would just be itself again, which is e to the n. So we would write that as f prime of n equals e to the n. This would be our answer here for number 1. Now number 2. Now we see the natural log of n. Usually we would use the derivative shortcut of when dealing with natural logs or logarithms, and it would be 1 over x. In this case, the derivative of this would simply just be p prime of m equals 1 over m. This would be our answer here. Number 3, we have h w equals 3. Now here we're going to just use what we call the constant rule, which is when we see a constant like any number by itself without any variables. So h prime of w would equal 0. That would be our answer that would be our derivative, rather. We have r of q equals negative 2q squared minus 3q plus 5. So we are going to actually, like I had mentioned before, if there was a number out front here and the power up here, we multiply these. But if there's a number out front here, it's just a 1, just like when we saw a number 5. So we're going to actually multiply negative 2 by 4. Well, sorry, negative 2 by 2, which will give us negative 4q 1. Remember, when we have an exponent, we use the power rule to subtract 1 from the exponent, which is why we have lowered our exponent from 2 to 1. Now, our next term is going to be, it's minus 3q. Well, once again, using the power rule, 1 minus 1 equals 0. So we have minus 3. And here, for the plus 5, that's just a constant. It would technically be plus 0, but we don't have to put that in there because it doesn't make a difference in our answer. So our final answer would be r prime of q equals negative 4q minus 3. We also don't have to necessarily put the 1, but it helps sometimes to visualize how the degree, or rather the exponent, is changing on the function itself when we take the first derivative. Okay, so now we have it's still basic derivative, but it may be a little bit more complicated because we have a square root thrown in here. But we can get through any derivative using the shortcut rules. So once again, we have 4t to the third power. So what are we going to do again? We see a number out front and the exponent. We multiply these two together and bring the power of the exponent down. So it's going to be 12t squared. That would be our derivative of our first term. Now our second term says 7 times the square root of t. A way to help us to get through this derivative is rewriting the square root as a fraction. So the square root of t here, for our side note here, it's just simply going to be t1 over 2. Now we would put plus 7t1 over 2 plus 8. Now, we would, to take the derivative of this, we would actually multiply 7 times 1 divided by 2. And that would actually be 7 over 2 t. Now, because we multiply 7 by 1/2, we want to, again, remember, use the power rule to bring that power down. So a half minus 1 is negative 1/2. And our final answer would be a prime of t equals 12t squared plus 7 over 2t to the negative 1/2. Now, I only wrote the constant here because I wanted to keep track and make sure that I took the derivative of all my terms. So this 8 would technically be a 0, but it's not going to affect our answer, so we don't have to write it. This would be our final answer here. Do q prime of p equals, so 2 divided by 3 times 3 is going to give us a 2. Now, we want to bring our exponent down, so we would be at 2 plus, again, 4 divided by 5 times 2 is 8/5 p, because we want to subtract 1 from our exponent. And when we subtract 1 from our exponent, this is also known as using the power rule. Now, this 9 here, again, it's a constant. It's a 0. But we don't have to add it once again because it's not going to change our answer here. So our answer would be q prime of p equals 2p squared plus 8 divided by 5p. That would be our answer for 9. Please like, comment, share, and subscribe. And I'll be back at it again with another video on derivatives.